Okay, this is lesson 3.1 and continuing on with that, and we're using the intermediate value theorem to prove x cubed plus 2 equals to sine x is solvable on the interval from -2, closed interval from -2 to 1. Okay, problem here. We have an f of x, but our m has to be a constant. So we've got to move this sine x over, so we have to apply negative sine x to both sides. So we've got here a function f of x equals to x cubed plus 2 minus sine x equals 0. So this is our f of x, and this is our m. So now we have a constant for m. All right, so now we're ready to define our function. So let f be a continuous function, continuous function. F of x is equal to x cubed plus 2 minus sine x. On the closed interval, a -2 to -1. Okay, next, assume that m equals 0 is between f of -2 and f of -1. So m is greater than f of -2 and less than f of -1. Then there exists at least one number C on the interval. Okay, there exists one number C on the interval from -2 to -1, which satisfies f of c equals m. In other words, that all this equals to 0. All right, so you have to define. You can't skip this, okay? Because you're proving this function through the intermediate value theorem, and you have to define it. So you can't skip this. You can't just go to the calculations. You have to define it. Okay. So from here, now it doesn't have to be exactly word for word, but it's got to be fairly close. So we have here f of -2 equals to -2 cubed. So we're doing the left endpoint now. Okay. So that's f of -2 plus 2 minus sine of a -2. Okay, so we've got to put this in our calculator. All right, now let's look at this for a minute. So first thing you have to do is check and make sure in mode that you're in radians, okay? Because if you're in degrees, it's going to come out wrong. Okay, so because if it, so we're going to put in here negative 2 cubed plus, oh, be careful. You have to make sure that you see how this is still up here in the exponent. You have to hit the right arrow to get it out of exponent. Otherwise, you're going to have everything after that all up in the exponent. That's not going to be a good answer. Plus 2 minus sine negative 2. Okay, and we hit enter, and we get negative 5.09. So we're just going to round that. We're just going to say negative 5. So that's approximately equal to a negative 5. Well, negative 5 is less than our m, right? So that's less than 0. So we can say that f of negative 2 is less than m, okay, which is less than 0. All right, so now we're ready to do the other one. So now we do the right endpoint at negative 1. So we put in negative 1 cubed plus 2 minus sine at negative 1. Okay, and so we calculate that and we get 1.8. Well, 1.8 is greater than 0, so we can say that f of negative 1 is greater than m, since m is 0, right? We established m is 0. So if we were to graph this, okay, then we would, and here's negative 1 and here's negative 2. We're saying that one value is way down here, negative 5, negative 2, and there's some, so this is f of negative 2, and this is f of negative 1, and this is some number c, excuse me, where we have m equals 0. Okay, so that's what we're looking at now for this particular problem. If you were to graph this is basically what you would see from, I'm just looking at from negative 2 to negative 1. Okay, so from here we can state that such that f of negative 2 is less than m, which is less than f of a negative 1. Now, if this was reversed, if this was positive, this was 5, and this was a negative 1.8, then you would have to reverse it. You'd have to say f of negative 2 is greater than m, and m is greater than f of negative 1. But it's not. It's negative and positive. So this is how we've got it. Just letting you know that it's not always going to be less than and less than. It could be greater than and greater than. Thus, m equals 0 is between f of negative 2 and f of negative 1. Thus, the assumption of the intermediate value theorem has now been met. Therefore, we can conclude there is some number is some number. We see there's some number C on the interval -2 to -1 closed interval, which satisfies f of c equals m. And bam, we're done. We're there. We're proving it. And that concludes this